Hi, this is Lakshmi Kantiwari. In this lesson, I'm going to teach you about ensemble learning in machine learning using a Python. So in this lesson, I'll be first describing you what is the ensemble learning, and then I'll be giving you an example with the cricket team, and then I'll take you through why ensemble learning is required. Then I'll explain you bias and the variance trade-off, and then I'll explain you how you can understand that whether your model is overfit or it is underfit. After that, we will look ensemble learning, types of ensemble learning. Then I'll be explaining you what are the algorithm based on the bagging ensemble learning and what are the algorithm based on the boosting ensemble learning. Okay, and then I'll be taking you through the max sorting, averaging and the weighted average techniques, the bagging and the boosting. And then finally I'll be explaining you the algorithm which I am going to teach you in this lesson. And those algorithms are the random forest, XGBoost, AdaBoost and the gradient boost. And then after that I'll be taking you through the breast cancer data set, and then we will be preparing our data set, and then finally we will be making our full model, and then finally we will be testing it with the accuracy, and we will be doing a comparison of the accuracy for a different model. Okay, so this is all about in this lesson. Now let's go ahead without wasting your time. Let's go ahead and start this brand new lesson. Ensemble learning uses multiple machine learning models or a multiple set of models for the same algorithm which try to make a better prediction. So here is an example for this. Let's suppose that you have a particular data set where an ensemble model works by training different models on this data set, and having each of these models makes a prediction individually. And once the prediction is made, then the results are combined with some statistical methods, and then finally a final predictions is made. So this is how ensemble learning works in a machine learning. So the moreover, in one sentence you can say that there is a data set where multiple algorithms are trained on a same data set, and then finally predictions are made based on the outcomes of these individual machine learning algorithms. Right, perfect. So let's take it with an example here. Let's suppose that you have a cricket team. In a cricket team, you see there are many players. Okay, let's say for the many players, the few players are for specialized in the batting, and few for wicket keeping, a few for fielding at the middle order, and a few are spinners, and a few are fast bowler. So the cricket teams are the team are made in such a way that the few people are specialized in some field or in a field. Okay, in the same way, in this algorithm, let's say for a data, this algorithm is specialized for a particular set of the data, for particular feature set, and this algorithm is, let's say, specialized for a particular set, and this is for particular, and this is for particular. So in this way, how it works, there are multiple algorithms and they are specialized in some way, in some field, and then once we combine the result of all these algorithms together, then it makes the final predictions are very better. Okay, so the moreover, this is how we can say how it works. Now the question comes, why ensemble learning? Okay, so once we start with the ensemble learning, attempt to achieve high accuracy by using a single algorithm might end up with overfitting. Okay, so every model has its strength and the weakness. Ensemble models can be beneficial by combining individual models to help hide the weakness of an individual model. For example, like I explained you in a cricket team. Okay, so the similarly happens here. Let's say this one has some weakness, but the same weakness which this model have, this doesn't have. So the moreover, if we combine the result from all these the models together, then we can cover the weakness of all these weakness from all these individual models. Okay, perfect. So but what happens if we apply the algorithms in our machine learning? It creates some type of the error. Okay, and the error emerged from any machine models can be broken down into three components, and those components are the bias, variance, and irreducible error. That's when this error cannot be reduced, although the bias and the variance can be reduced. So you can understand here the bias and the variance trade-off in this figure. So this is a very famous the statement, bias and the variance trade-off. So after a certain point, if we start decreasing a bias, then the variance start increasing. So what we say here, the somehow we can say here that the bias and the variance are a kind of the reciprocal to each other. So if we start decreasing the bias here, you will see here the variance is start the increasing. So that means if we decrease the model complexity, then the bias will be high, and if we increase the model complexity, then the bias will be low but the variance will be high. So there has to be a sweet spot. Okay, so this is known as a sweet spot where we choose the particular bias and the variance so that our model performs the best. Okay, the best is like this total error. Okay, so the error start decreasing, but after a certain points error again start increasing. So this is how it works here. Let's say your model have low bias and low variance. So in this way, okay, so your predictions will be almost nearby to a final result or actual result. But if bias is low and the variance is high, then you will be always getting your the result around the actual result, but it will be there would be a standard deviation. But if bias is high, then you will be always getting a result somewhere far from actual, but the results will be concentrated if variance is low. But finally, if bias is high and the variance is also high, then you will be always getting the results far from actual, and also there would be high variance or standard deviation, whatever you see in your predicted result. Okay, so this is how this model complexity and error explained the same here, this trade-off. Okay, now let's go ahead and see how these bias and the variance are useful. So the bias error is useful to quantify how much on an average are predicted values different from the actual value. Okay, so that's the bias. Low bias means on average the predictions will be less, and high bias error means we have an underperforming model which keeps on missing essential trends. So you see here high bias. So high bias is this one. That's when the model complexity is low. Okay, so if bias is high, that's mean we have underperforming model. If bias is low and the variance is high, that's mean we have a overfitted model. Okay, with this figure we can say here. So by seeing just model performance, you can actually say that whether your model have high bias or high variance. Okay, that's mean if you are getting a high bias, then you have a very fair chance to increase model complexity in your model. But if you have a high variance, then you need to decrease model complexity to get a better result. So this is how the fundamental of machine learning works, and this is how you can always improve the your algorithm, machine learning algorithm. Okay, now let's go ahead and see a type of ensemble learning. So there are these are the few types of the ensemble machine learning, right? So basically these are the two. The first one is the basic ensemble the learning techniques, and another one is the advanced ensemble learning techniques. Okay, so here I'm gonna just make a quite space. Okay, I think we are not getting. Let me make it a space here so that we can okay, perfect. So here we have a type of ensemble learning, basic ensemble learning and advanced ensemble learning. In a basic ensemble techniques, we have a max sorting, averaging and a weighted average. But in advanced ensemble techniques, we have a stacking, blending, bagging and a boosting. Okay. And apart from that, I'll be describing you bagging and the boosting algorithm in this lesson. Okay. So algorithm based on the baggings are bagging meta estimator and random forest. And algorithms based on boosting, those algorithms are ADA boost, okay, the GBM, that is the gradient boosting, adaptive boosting, XG boost, and here we have a light gradient boosting, and here we have a cat boosting algorithm. Okay, perfect. Now let's go ahead and see how these basic ensemble technique works. So here we have a max sorting, averaging and the weighted average. In max sorting methods is generally used for a classification problem. In this technique, multiple models are used to make a prediction for each data points, and the predictions by each models are considered as odd, and the predictions which we get from the majority of the models are used as the final predictions. For example, if you see here in this example, let's say these examples predicted there are 4 models, and in this 4 model, let's say the 3 models predicted 0 and this predicted 1. So in this way we will see here the 3 is voting for 0. That's mean we will predict final label as a 0. That's it. That is the max sorting. Okay, and especially max sorting used in classification. But the averaging, similar to max sorting techniques, multiple predictions are made for each data points. Okay, and but after that we take average for each the predictions. So the basically average we use into a regression problem. Okay, where we need to provide a continuous value. Since in max sorting, in classification, we cannot provide the continuous value, but we can provide the probability. So averaging basically used into a regression, but averaging can be also used to get a probability of being some label. And then finally we have a weighted average. In weighted average, this is an extension of the averaging methods. All models are assigned different weights, defining the importance of each model for prediction. For instance, if we say this example, let's say this lasso has a 50% importance, and this has 20, this has 20, and this has 10%. So what we do, we take the labels of this one and multiply by 0.5 plus 0.2 multiplied by this label plus 0.2 multiplied by this label plus 0.1 multiplied by this label, and then finally we make a final prediction. So this is how weighted average works. Okay, perfect. Now let's go ahead and see what are the bagging and the boosting algorithms. Okay, and in the bagging we will be learning about the random forest in this lesson, and in the boosting we will be taking 3 algorithms: ADA boost, gradient boosting and the XG boost. Okay, perfect. So in bagging, bagging also known as a bootstrap algorithm. Okay, so the bagging is a sampling techniques in which we create a subset of observation from the original dataset with a replacement, and the size of subset is the same as the size of the original set. So the bagging is the random forest is a perfect example of a bagging. So random forest creates a multiple subset like a decision tree, a multiple decision tree, and then random forest make a prediction for each decision tree, and then finally random forest takes, if random forest is a classifier, then it takes a max sorting. If it is a regressor, then it takes a averaging from each of these the subset of the trees. So this is how bagging algorithm works. But in the boosting algorithm, boosting is a sequential process where each subsequent model attempts to correct the errors of the previous model, and the succeeding models are dependent on the previous model. And we can understand this with the below image, where let's say we have here our original data set, and our first algorithm creates here a plane there, let's say a plane here, And for that, let's suppose that we have the SVM classifier and random forest classifier and something else classifier, let's say the XGBoost. Okay, so here how it works. In this classifier, it first classify here, and it found out that there is the sum error. This plus point has came into the -1, and this negative has came into the +1. Okay, so we fit here the another algorithm, which algorithms identify these two. Okay, so this algorithm identify these two, and then that's mean after this data set, after this model, then we train another model on the same model, then that identify this one, and then again we trained another model which identify this one, and then finally we mix all these three models together, and that makes this model, and which perfectly classify our original data set. So that is the combined classifier. This is how a boosting algorithm works. So in bagging we will be learning here random forest, and in a boosting we will be learning XGBoost, AdaBoost and a gradient boosting. Okay, so random forest algorithms I have already taught. You can go ahead and watch it at my channel KGP Talkie there, and that is here random forest classifier and the regression in machine learning using a Python. So the random forest is a Ensemble machine learning algorithm that follows the bagging techniques. It is an extension of a bagging estimator algorithms, and XGBoost is an advanced implementation of a gradient boosting algorithm. Okay, and the XGBoost has proved to be highly effective ML algorithm, although it takes a little more time to train and test. And the adaptive boosting or AdaBoost is one of the very simplest boosting algorithm. Usually multiple sequence models are created, as I explained earlier there. Okay, and then sequentially it classify. And the gradient boosting is another Ensemble machine learning algorithm that works for both regression and the classification problem. So the gradient boosting algorithm uses the boosting techniques combining a number of weak learners to form a strong learner. And now let's go ahead and see an example for each of these Ensemble machine learning techniques. So the first of all, I'm gonna import a basic libraries like pandas, seaborn, matplotlib and the numpy, and then I'm gonna import here the dataset and the metrics from sklearn, and then I'm going to import here the train test split, and then finally standard scaler, since we need to standardize or normalize our dataset before applying to any machine learning algorithms to get a better result. So let's go ahead and run this cell, and I'm going to also run this cell, and we are going to work into a breast cancer dataset. Okay, in this lesson. So the breast cancer dataset, here I'm going to load that with the datasets.load breast cancer in a cancer variable. Now once we have that, after that I'm gonna see here the description of this cancer dataset, that we can see here the print, and then the cancer the description. Okay, so there you see here in the cancer this is kind of the tumor. It detects the tumor, whether tumor is malignant or benign. So it has total 569 instances, and there are 30 the numeric attributes, which is 30 features. Okay, so in this we are going to work with this cancer. Now let's go ahead and get our x and the y variable. The x, that's mean the feature vector. The feature vector is placed into cancer.data. If you want to know more about this dataset, go ahead and watch my previous videos. I have been working on this breast cancer dataset previously on so many other machine learning algorithms. So you can go ahead and watch my previous videos. Okay, so here let's go ahead and get the label into y cancer.target. Now let's go ahead and see the shape of x and y. Here we have x shape and y shape. So there you see 569 instances are there and 30 features are present there. And after that I'm going to call a standard scalar. In a standard scalar we will get here scalar is equal to standard scalar, and in standard scalar we have x underscore scaled is equal to scalar dot fit underscore transform. Okay, so there we have here our the transformed x there. Now you can see here x is scaled in it. Sorry, something is wrong here. It's a transform. Okay, it's a transform. Now you see here, now x scaled will be always somewhere in between -3 to +3. So this is how standardization work. If we standardize any data set, then its data set can be somewhere in between -3 to +3. Now let's go ahead and create the ML models. To create the ML models like random forest, ADA boost and the gradient boosting, we need to import those from the sklearn Ensemble Learning. Okay, so here we get sklearn.ensemble and then import here random forest classifier and then ADA boost classifier, and then we have here the gradient boost classifier, and then I am going to import here XGBoost as XGB. Okay, now let's run this. But the problem is here, if you run this XGBoost, you might get an error that XGBoost does not exist or it doesn't found this one. Okay, so what you need to do, you might not have this one, then you need to install XGBoost. Let's go ahead and paste this. Okay, then Python install, you need to search here Python install and you need to get here XGBoost first. Then you can go ahead and get this XGBoost. You can run pip install XGBoost. It will install XGBoost on your computer, and once it is installed, then you can import XGBoost as XGB. Okay, perfect. Now let's go ahead and train test split our data set, that is X scaled. We are going to train test split into X train and X test, then Y train, and then finally Y test is equal to train test split. And there we have X scaled, X scaled, and then here we have Y, and then we have finally here test size, that is 0.2, and then we have here random state is equal to 1, and then here we have stratify. Okay, stratify is equal to Y. Perfect. Now let's go ahead and create our the model RFC, that's the random forest. In there we are going to pass random forest classifier, n estimator. How many estimators? That's gonna be 200. You can take anything. Okay, so 50, 100 or 150, it depends your machine learning capability. Now after that I'm gonna take ABC, that's the ADA boost classifier. In ADA boost classifier I'm gonna pass here n estimator 200, and then the random state is gonna be 2, and here the learning rate I'm going to pass here 0.01. okay, and then here I'm gonna get here the GBC, that's the gradient boosting classifier, and there in gradient boosting classifier I'm gonna pass here n estimator 200, and the random state is equal to 1, and similarly the learning rate which I'm gonna pass here, that's the 0.01, and then finally I'm gonna take here the XGB. okay, that's the XGB CLF. okay, XGBoost classifier, that's the XGB dot XGBoost classifier, and then n estimator is the 200 there, and here we have learning rate is 0.01, and then here we have a random state is equal to the 1. Now here you see here we have instances of our 4 machine learning algorithm: random forest, ADA boost, gradient boosting, and the XGBoost. Now let's go ahead and fit all these 4 models with your X train and the Y train dataset. So there we have here RFC dot fit, and there we have x underscore train, and then here we have a y underscore train. Let's go ahead and copy this fit. After that we have here abc dot, we need to copy this whole fit. So here we have fit x train and the y train, abc dot this one, and then we have a gbc dot fit x train and the y train, and then we have here the xgb the clf, okay, and then dot fit x train and the y train. Let's go ahead and fit this model. It will take a while to fit all these models. Now we have all these our 4 models. Let's go ahead and print the accuracy for each of these models now and see what is the performance of these ensemble machine learning algorithms. So the first I'm gonna get from the random forest. Okay, so in random forest we have rfc dot score, and there we have x underscore test and then y underscore test. Okay, after that let's go ahead and copy this, paste it 4 times. Oops. Okay, so this should be the small print actually. Okay, now for this is for not random forest actually, this is for Ada Boost, and this one below is for gradient boost, and here we have last one for xg boost. Okay, so this one would be the abc, and this one would be the gbc, and this one would be xgclf. Okay, so here we have accuracy for random forest, Ada boost, gradient boost, and the xg boost. Okay, now perfect. Let's go ahead and run this. Perfect. Now you see here in random forest we have got 94%, 94.73. In Ada boost we have got a 94.73, but in the gradient boost we have got 97.36, and in xg boost we have got a 95%. So you can see here how this ensemble algorithms has increased the accuracy of this classification.